Okay, today's lecture is on Fourier series and Fourier analysis. We are starting the lecture Fourier series. First of all, French mathematician Fourier gave the theory of Fourier series and Fourier analysis. This is the first point. The French mathematician Fourier gave the theory of Fourier series and Fourier analysis. Next, we write down what is the Fourier theorem or Fourier series. Fourier theorem. Fourier theorem says that any single valued periodic function f of x with period alpha to alpha plus 2 pi with period alpha to alpha plus 2 pi which is continuous if not piecewise continuous. Piecewise continuous having finite number of maximum and minimum finite value and defined in the closed interval may be retained in the form f of x, this is equal to a0 by 2 plus summation over n 1 to infinity a n cos nx plus summation over n 1 to infinity b n sin nx. This series is known as Fourier series. This series is known as Fourier series. or Fourier theorem or Fourier theorem, Fourier series or Fourier theorem. Of f(x). The coefficient a0, an, bn, the coefficient a0, an and bn in the series are known as Fourier coefficient. In the series are known as Fourier coefficient. An is called Fourier cosine coefficient, and Bn, because an is related with cos term, cosine term, that is why it is called Fourier cosine coefficient, and Bn is called Fourier sine coefficient, because it is related to sine term. And the values of the coefficient a0, an and bn are given by a0 equal to 1 by pi alpha 2 alpha plus 2 pi f of x dx, an equal to 1 by pi integration alpha 2 alpha plus 2 pi f of x cos nx dx, and bn equal to 1 by pi integration alpha 2 alpha plus 2 pi f of x sin nx dx. The above three integrals a0, an and integral for bn, above three integrals are known as Euler's integral or Euler's formula. Euler's integrals or Euler formula. So this is the Fourier theorem. If any function f(x) is given, we can write it as a summation of sine function and cos function with the values of a0, an and bn known as Fourier coefficient are given by this integration. Now any function, the function which can be expressed in Fourier series has to satisfy some condition. First condition there is it should be periodic function, it should be single valued. Single valued means single valued function. Single valued function means for every value of a variable, function should have only single value. That is called single valued function. As for example, f of x, this is equal to x. For particular values of x, we have only one value of f(x). So this is a single valued function. But if f of x equal to root of x, then for single values of x, f of x will be two values more than one. So, in this case it is not single valued function. So, first condition is that the function should be single valued. Single valued means for each value of the variable function has only one value. Then function should be continuous. Function should be continuous. Continuous means continuous. Continuous means suppose the function is defined in the interval. Function is defined in the interval x equal to alpha to x equal to alpha plus 2 pi. In this interval, function is defined at every point. At every point in this interval, function is defined. At every point of this interval, function can be differentiated, and in the whole interval, it is defined by only single function f of x. This is called continuous function. I am repeating this, the meaning of continuous. Continuous means at every value of the, at every point, function can be defined, it should be differentiable, and over the whole interval, function can be differentiated, but function can be described by only a single function f of x. And it is not continuous. If it is not continuous, then it should be piecewise continuous. Piecewise continuous means, suppose it is piecewise continuous, then in the whole interval x equal to alpha to x equal to alpha plus 2 pi, we can find a point x equal to a. Then x equal to alpha to x equal to a, in this interval function f of x can be defined some function phi x, and in the interval x equal to a to x equal to alpha plus 2 pi, function can be defined by another function phi x. This is contrast to the continuous function. In continuous function, when the function is continuous, in the whole interval, function can be defined by single function f of x. But if the function is not continuous, it is piecewise continuous, then in suppose at the point x equal to a, in the left side of the x equal to a, we can define by phi x, in the right side of x equal to a, we can define by psi x, and at the point x equal to a, the value of the function will be phi of a plus psi of a divided by 2. This is the meaning of piecewise continuous, and function should have finite number of maxima and minima. Function should have finite number of maxima and minima. If this is the interval of the function, then in this interval it should have maxima or minima, but this number of maxima, here number of maxima is 4, number of minima is 3. A number of maxima and minima should be finite, and also the value of the minimum of the function or value of maximum of the function in this interval will be also finite. The number of maxima minima will be finite, and value of the function and maximum point and value of minimum value of the function will be also finite. So, this is the finite number of maxima and minima. So, this is the condition. If a periodic function satisfies this condition, then we can express it in a summation of sine series function and cos function, which is known as Fourier series. And these conditions are known as famous Dirichlet condition. Dirichlet condition. This condition is known as Dirichlet condition. Another point to mention here that Dirichlet conditions, another point is that Dirichlet condition conditions are necessary but not sufficient, that is, if a function satisfies Dirichlet condition, it can be expanded in Fourier series, but a function representing the solution of a physical problem in the form of sine and cosine as a in the form of summation of sine and cosine series, in the form of summation of sine and cosine series, may not satisfy Dirichlet conditions. May not satisfy Dirichlet conditions. So, this is the Dirichlet condition, and if a function satisfies Dirichlet condition, then we can write it in the summation of sine and cosine series, which is known as Fourier series, and the Fourier values of the Fourier coefficient are given by Euler's integral. Now, I want to mention some basic points, what is periodic motion and what is the periodic function. So, periodic motion, a periodic motion is that which repeats itself after a regular interval of time. Periodic motion, some basic point, periodic motion. Periodic motion is that that repeat itself, motion that repeats itself after a regular interval of time, that repeat itself after a regular interval of time, that is called periodic motion. As for example, rotation of an electron round the nucleus. This is an example of a periodic motion, because this is the nucleus, this is the orbit of the electron. Suppose electron studies motion from this point, it rotates around the nucleus, then again starts from this point and rotates around the nucleus, and the time required for this motion in two cases is same. This is called period of the motion. This regular interval of time is called period of the motion. And frequency n means number of complete oscillations per unit time. N, this is equal to 1 by capital T. So, like periodic function in physics or in mathematics, there are some functions which behaves periodically, they are called periodic functions. So, periodic function. Periodic function. Periodic function. Periodic function. Function like periodic motion, a function that repeats itself after a regular interval of time, a function that repeats itself after a regular interval of time capital T, that is called periodic function. Capital T is the period of the function. In previous case it was the period of the motion, now it is the period of the function. And as the suppose function f, this is a function of variable time t, and capital T is its time period. So, f of t will be f of t plus capital T, because after the time capital T function attains the same value. So, f of t equal to f small t plus capital T. So, there are many examples of periodic function in physics. As for example, real physical example হচ্ছে alternating current, alternating current, alternating voltage, all are periodic function, because the equation for alternating current equal to I0 sin omega t, and alternating voltage Vt equal to V0 sin omega t. I0 and V0, I0 is the peak value of the current and V0 is the peak value of the voltage, amplitude of the current and voltage. T is the time at any instant of time, omega is the angular frequency, and omega equal to 2 pi n or 2 pi by capital T. N is the linear frequency, omega is the angular frequency. Now we show that what is the variation of sine function. Suppose f of x equal to we can show it from this equation, I t equal to I0 sin omega t, then I t plus capital T equal to I0 sin omega t plus capital T, তাহলে I0 sin omega t plus omega capital T, তাহলে I0 sin omega t plus 2 pi, so 2 pi plus omega t, তাহলে I0 sin omega t, I0 sin omega t. So, if this is the form of the alternating current, then I t plus capital T, this is equal to I t. So, this is satisfies the properties of periodic function. So, alternating current, alternating voltage, all are periodic function. Okay, another example of periodic function is that, suppose this is our function, this is time t, this is function f of t, this is half time period t by 2, this is half time total time period t. So, what the half time period, this is equal to small small h, and this is equal to 0. Again from t, this is equal to h, then this is equal to 0. So, f of t equal to h for 0 less than equal to t less than equal to t by 2, and this is equal to 0 for t by 2 greater than equal to t greater than equal to t. So, this is another example of periodic function. There are different types of periodic function, but sine function and cos function is the most simple periodic function. So, if we can express any periodic function in terms of sine function and cos function, then it will be more easier. We need not study all types of periodic function. This is the requirement, this is the advantage of Fourier series. So, in Fourier series, we express all types of periodic function satisfying Dirichlet condition as a summation of sine and cosine function, because sine function and cosine function is the most simple and easiest periodic function. So, calculation becomes simpler and we need not study separately all types of periodic function. Another point is that when a periodic function is written as a summation of sine and cosine function, this process is known as Fourier analysis. In reverse process, when sine and cosine function থেকে Fourier periodic functionটাকে we get back the periodic function, actual periodic function. This process is known as Fourier synthesis. Okay. Another one simple question, that tan x cannot be expanded in Fourier series, in the interval minus pi to plus pi. Tan x cannot be expanded in Fourier series in the interval minus pi to plus pi. First of all, we draw the tan x in the interval minus pi to plus pi. Suppose along y axis we are taking tan x, and along x axis this is our function x. So, this is minus pi, this is equal to 0, this is equal to plus pi, this is equal to plus pi by 2, this is equal to minus pi by 2. So, this is the nature of tan x. Tan x is a periodic function, but this is the nature of tan x, and which is infinite at plus pi by 2 and minus pi by 2. So, tan x does not satisfy all the Dirichlet conditions. So, it cannot be expanded in Fourier series in the interval minus pi to plus pi. Now, evaluation of Euler's integral. Evaluation of Euler's formula or Euler's integral. Basically, we are evaluating the integral by expression of a0, an and bn. So, let f of x, this is equal to a0 by 2 plus summation over n 1 to infinity an cos nx plus summation over n 1 to infinity bn sin nx. This is the full expression of Fourier series. This is the expression of Fourier series, and we want to find the value of a0, an and bn. Now, f of x, integrating both sides, f of x dx alpha to alpha plus 2 pi, integrating both sides over the period alpha to alpha plus 2 pi, this is equal to a0 by 2 dx alpha to alpha plus 2 pi plus summation over n from 1 to infinity an integration alpha to alpha plus 2 pi cos nx dx plus summation over n equal to 1 to infinity bn integration alpha to alpha plus 2 pi sin nx dx. One point to mention there is a summation and we are taking integration. Integration is with respect to x and summation over the n. So, we can find the summation out, we can take the summation out from the integration, and then now we first integrate this cos nx dx and sin nx dx. So, integration alpha to alpha plus 2 pi cos nx dx. Basically, this should be equal to 0 because cos function, sin function is periodic function, and the periodic function of an integration over the period alpha to alpha plus 2 pi is equal to 0. So, cos nx equal to sin nx divided by n integration alpha to alpha plus 2 pi. This is equal to 1 by n sin n x alpha to alpha plus 2 pi minus sin n alpha. Then 1 by n sin n alpha minus sin n alpha, this is equal to 0. Sin n alpha plus 2 pi, this is equal to n alpha, because suppose this is all sin, tan, cos. In this quadrant all are positive, sin, cos, tan, cosec, all are positive. Alpha plus 2 pi, n alpha plus 2 pi. So, this is, if we make one rotation, this is 2 pi. So, n 2 pi means we have to make n complete rotation, then alpha, this is equal to n alpha, and n alpha is less than 90 degree. So, this is sin n alpha minus n equal to 0. Similarly, if we integrate sin nx dx over the total period, this will be also equal to 0. So, this is equal to 0 and this term is also equal to 0. Therefore, alpha 2 alpha plus 2 pi f of x dx equal to a0 by 2 x এর ইন্টিগ্রেশন alpha 2 alpha plus 2 pi, this is equal to 0, this is equal to 0, তাহলে a0 by 2 alpha plus 2 pi minus alpha alpha কেটে যাবে 2 কেটে যাবে তাহলে a0 pi হবে। Therefore, a0 equal to 1 by pi integration alpha 2 alpha plus 2 pi f of x dx. This is the first Euler integrals which gives the Fourier coefficient a0 equal to 1 by pi alpha to alpha plus 2 pi f of x dx. Next, we find the integration Euler's second integral which gives the value of a n. So, f of x cos mx a0 by 2 cos mx plus summation over n 1 to infinity a n cos nx cos mx plus summation over n 1 to infinity b n sin nx cos mx. First we multiply both sides by cos mx. We have to remember that this m should be different than n. This should be different index. Now we integrate both sides with respect to x over the interval alpha to alpha plus 2 pi. So, f x cos mx dx integration alpha to alpha plus 2 pi. This is equal to first term from this term a0 by 2 integration alpha to alpha plus 2 pi cos mx dx plus summation over n from 1 to infinity a n integration alpha to alpha plus 2 pi cos mx cos nx cos mx dx plus summation over n from 1 to infinity bn integration alpha to alpha plus 2 pi sin nx cos mx dx. Again this integration alpha to alpha plus 2 pi cos mx dx, this will be equal to 0. We have shown previously because this is a periodic function and periodic function of a integration of a periodic function over the whole period is equal to 0. Now, first we are evaluating alpha to alpha plus 2 pi sin nx cos mx dx. So, this is equal to half, we can proceed in this way, half alpha to alpha plus 2 pi 2 sin nx cos mx dx. This is equal to half integration alpha to alpha plus 2 pi to sin a cos b, to sin a cos b equal to sin a plus bx, sin a plus bx minus sin a minus bx dx. So this is equal to half, then integration minus cos n plus mx divided by n plus m integration alpha to alpha plus 2 pi minus 1 by n minus m minus to minus plus cos n minus m x integration alpha to alpha plus 2 pi. Okay, as if n equal to m is n equal to m, this will be 1 by 0 which diverges. So this process is valid for n not equal to m. So for n not equal to m, so for n not equal to m, this is equal to half minus 1 by n plus m, 1 by n plus m cos n plus m alpha plus 2 pi minus cos n plus m alpha, then plus 1 by n minus m cos n minus m alpha plus 2 pi minus cos n minus m alpha. So this is equal to half. So this is equal to basically cos n plus m. So this will be equal to 0. This will be also equal to 0. So this is equal to 0. So half integration alpha to alpha plus 2 pi sin nx cos mx dx is equal to 0 for n not equal to m. And it will be also equal to 0. It will be also equal to 0 for n equal to m also. So for n equal to m, integration alpha to alpha plus 2 pi alpha plus 2 pi sin nx cos nx dx. So here n equal to m. So this is will be equal to half into integration alpha to alpha plus 2 pi to sin nx cos nx dx. This is equal to half sin 2 nx dx integration alpha to alpha plus 2 pi. So half sin n integration minus cos 2nx divided by 2n alpha to alpha plus 2 pi. So this will be equal to minus half cos 2n alpha plus 2 pi minus cos 4n, basically 4n 2n alpha. So this will be also equal to 0. So this term is equal to 0 both for n equal to m and for n not equal to m. In the same way, we can prove that. Integration alpha to alpha plus 2 pi cos nx cos mx dx, this is equal to 0 for n not equal to m, and this is equal to pi, this is equal to pi for n equal to m. In these two result can be written in this way: alpha to alpha plus 2 pi cos nx cos mx dx, this is equal to pi delta mn, where delta mn is known as Kronecker delta. Kronecker delta. So this is delta mn equal to 0 for m not equal to n, equal to 1 for m equal to n. So now we can write integration alpha to alpha plus 2 pi f of x cos mx dx, this is equal to a0 by 2, a0 by 2, this is equal to 0, this is equal, this time equal to 0, this time equal to 0. So we are left with n 1 to infinity an pi delta m n. So this will basically m, because n is a dummy index, running index, and when n equal to m, we will get the value pi, non-zero value. So am pi. Therefore am equal to 1 by pi integration alpha to alpha plus 2 pi f of x cos mx dx, or an equal to 1 by pi integration alpha to alpha plus 2 pi f of x cos nx dx. This is the second Euler integral. This is the second Euler integral, n equal to 1 by pi alpha to alpha plus 2 pi f of x cos nx dx. In the same way, we can also evaluate the third integral, third Euler integrals, that is the expression of Bn. So we can again write f of x, this is equal to a0 by 2 plus summation over n from 1 to infinity, an cos nx plus summation over n from 1 to infinity, Bn sin nx. So f of x, multiply both sides by sin nx, then f of x sin mx dx integration alpha to alpha plus 2 pi, this is equal to a0 by 2 integration sin mx dx integration alpha to alpha plus 2 pi plus summation over n from 1 to infinity, an alpha to alpha plus 2 pi cos nx sin mx dx plus summation over n from 1 to infinity, Bn integration alpha to alpha plus 2 pi sin nx sin mx dx. So this is a periodic function, this will be equal to 0. So again this cos nx sin mx are 0 both for n equal to m and m not equal to n, because cos nx sin nx are called orthogonal function. They are always equal to 0. When we integrate by producting them, this will be equal to 0, and this will be equal to 0 and this term. So we are left with alpha, again sin nx cos mx will be equal to 0 for n equal to n not equal to m, and will be equal to pi for n equal to m. So alpha to alpha plus 2 pi f of x sin mx dx, this is equal to summation over n 1 to infinity bn pi delta mn. So, this is equal to bm. Therefore, bm pi, this is equal to bm pi. So, bm, this is equal to 1 by pi integration alpha to alpha plus 2 pi f of x sin mx dx, or bn equal to 1 by pi integration alpha to alpha plus 2 pi f of x sin nx dx. This is the third Euler integral. Now, if as we have find the values of a0, now we will illustrate the process with a simple example. Suppose f of x, this is equal to 0 for minus pi less than equal to x less than 0. This is equal to h for 0 less than x less than equal to y. Now we expand it in the Fourier series. Suppose in the first we evaluate a0. a0 equal to 1 by pi minus pi to plus pi f of x dx, or 1 by pi minus pi to 0 f of x dx plus 0 to pi f of x dx. So, this is equal to 0. So, 1 by pi integration 0 to h 0 to pi h dx, or h by pi x 0 to pi, or h by pi pi minus 0, this is equal to h. So, this is the value of a0. Now, we will evaluate an. an equal to 1 by pi minus pi to pi f of x cos nx dx. This is equal to 1 by pi minus pi to 0 f of x cos nx dx plus 0 to pi f of x cos nx dx. So, this is equal to 0 as f of x equal to 0 in the interval minus pi to 0. So, this is equal to 1 by pi 0 to pi h cos nx dx. So, this is equal to h by pi cos nx minus sin nx by n, plus sin nx by n 0 to pi. So, this is equal to h by n pi into sin n pi minus sin n into 0. This is equal to 0. So, bn equal an equal to 0. So, a0 equal to h. So, a0 equal to h and an equal to 0 for this function. So, a0 equal to h, an equal to 0. Now, we will find bn. bn equal to 1 by pi minus pi to plus pi f of x sin nx dx. 1 by pi integration minus pi to 0 f of x sin nx dx plus 0 to pi f of x sin nx dx. This is equal to 0. So, 1 by pi 0 to pi h sin nx dx. This is equal to h by pi, sin means cos nx divided by n 0 to pi h by pi n minus sign cos n pi minus cos n 0. তো মাইনাস এইচ বাই এন পাই, স্যার মাইনাসটা কমন নিশ্চয়ই, মাইনাস কমন 1 মাইনাস মাইনাস 1 টু দ্য পাওয়ার n. সো দিস ইজ ইকুয়াল টু এইচ বাই এন পাই, this is equal to 0, n is even, 0 for n equal to even, and this is equal to h by 2n pi, h by 2h by n pi, 2h by n pi for n equal to odd. So with this expression, with the values of a0, an and bn, we can write the Fourier expansion of f of x. So f of x, this is equal to a0 by 2, this is equal to h by 2 for n equal to even, because in this case n equal to 0 and bn is also equal to 0, and f of x equal to a0 by 2 plus summation of n equal to 0, summation over n 1 to infinity bn sin n x. a0 by 2 means h by 2 plus summation over n from 1 to infinity bn equal to কত 2h by n pi sin n x. So if we expand it, then h by 2 plus 2h by pi sin x by 1 plus sin 3x by 3 plus sin 5x by 5, so on. So this is the Fourier series, this is the expression of Fourier series, this is the expression of Fourier series. That is all for today.